So what Pandas is really good at is storing big amounts of data, and then accessing this data conveniently and efficiently. To achieve that, Pandas uses a type defined within Pandas, whose purpose is just that, storing these big amounts of data and then accessing this data conveniently and efficiently. This type is the data frame, and it's one of the most basic and probably one of the most important things to know when starting out with Pandas. So let's get to know the data frame type and see how we can create data frame objects.
So to get started with Pandas, we first have to make sure that we have it installed. Assuming that you use pip and have it installed, all you have to do is pip install Pandas, and it will install Pandas on top of your Python installation. I already had Pandas installed, so nothing new was installed, but if I didn't have Pandas, it would be installed now. To make sure that Pandas was correctly installed, let's import it into our program. And the accepted shortcut for Pandas is pd, so import Pandas as pd. And let's run the script. And we got no errors or warnings, which means that Pandas is installed correctly. Now, the basic type in Pandas that we use to store data is the data frame. So let's see how we can define such a data frame of our own. To create a new data frame, we'll use the data frame constructor. So pd.dataframe. And make sure that when you write data frame in a Python program, the D and the F are uppercase. Let's now fill in the data for our new data frame. So first, all of the data is going to be inside curly braces. And once we have them, we need to define the data column by column. So let's assume that this data frame holds the grades of two students. Each of the two students is going to have its own column. Let's say that the name of the first student is Joe. So let's call the first column Joe. Right after the name of the column, we add a colon. And then we need to specify the data for this column. The data itself is based on a list, which means that we will provide it within square brackets. And within the square brackets, I'll write the grades for this student. So we're done with the first column. Let's now add the second column. So comma, and then the name of the second column, and let's say that the second student is Bill. And let's now provide the data for the second column. Now we basically built a table. This table has two columns, Joe and Bill, and two rows. And that's why you have two values for each of the columns. So let's save our data frame in a variable. And let's try to print it and see what we get. And here is the output data frame. So here are the two columns, Joe and Bill. Here is the data for the first column, and here is the data for the second column. Now that we have our data frame, we can access a specific column by using a dot and then the name of the column that we want to access. So let's say, for example, that I only want the data for the Joe column. So df.Joe. And let's see what we get now. And as you can see, we now got only two values. And these are the values for the Joe column. The numbers we got here are the indexes. So by default, each row uses its index as its name. So row 0 and row 1. Let's get back to showing the entire data frame. And as we saw, our columns have names we provided, Joe and Bill. But the rows don't have names, and they just use their indexes. If we want to name our rows, we can do that as well. All we need to do is give a value to the index parameter when creating the data frame. So let's try to do that. So comma. And now I want to give a value to the index parameter. Now we need to give a name to each of our rows. So once again, we're going to provide a list. And I just call my rows grade 1 and grade 2. And if we run our program now, we see that our data frame contains the same data, but now our rows have names, grade 1 and grade 2. Another important type in Pandas is the series. And a series is basically the representation of a list within Pandas, which means that it just contains a list of values, one after the other. To create a series, we can use the series constructor. So pd.series. And once again, make sure that the first S is a capital S. And as a parameter, we simply provide a list. So let's say that this list needs to consist of 2 numeric values. And let's try to print our series. Now you might notice that what we just got is very similar to what we got when we accessed a specific column within a data frame. And that's not by chance. In fact, the data for each of the columns of a data frame is a series. So we could say that a data frame consists of a bunch of series. Let's make it even more clear by accessing a specific column within our data frame, and then I'll print both of them side by side, the column from the data frame and the series. And as we see, they have the same structure. The only difference is that this one, the first one, has a name, and that's the name of the column we accessed. And the series itself has no name because it's not a column of any data frame. We can also print the type for both of these objects. And when we run it, we can see that both of them are of the type series. As we said, the purpose of Pandas is to work with big data sets. Many times we won't generate the data ourselves, but get it from someone else or from some software that generates it for us. One of the popular formats to transfer such big data sets is using a CSV file. And because of its popularity, Pandas has a built-in function to read CSV files. So first, let's download the CSV file we will work with. I'm going to download it from the Kaggle website, and I leave a link in the video description below. Now, to be able to download this dataset, you're going to need a Kaggle account, but it only takes a few seconds to create one. And once you will do that, you will be able to download the dataset from here. So I'll just click here. I already have an account. And now the dataset is being downloaded. And it will be downloaded as a zip file. So extract the zip file and place its contents next to your Python file. So let me show you the structure you need to end up with. So in my home folder, I have a folder called Python Workspace. And here I have my Python file. Next to this file, I have this folder, which I called datasets. And within the datasets folder, I have the 2 files I extracted from the zip file from the Kaggle website. So as you can see, I have a CSV file and also a JSON file. For now, we will be focusing on the CSV file, and it's important to understand its path relative to the Python file. So for me, I have the datasets folder, and within the datasets folder, I have the CSV file. Once we're done with that, we can read the CSV file using the read CSV function. So pd.readcsv. And here we need to provide the path to the CSV file relative to the Python file itself. So for me, it's going to be datasets / and then the name of the CSV file itself. And the output of the read CSV function is a data frame. So I'll save it in a variable called df. Now, usually, when we open a new data frame from a CSV file, we'll want to start with knowing its size. And we can do that using the shape field of the data frame. So let's print the shape of this data frame we just read from the CSV file. And let's run it. And you can see that this data frame has 129,971 rows and 14 columns, which is quite a lot of data. Now, this dataset holds reviews of wine tasters. So just for clarity, let's change our variable to wine reviews. Now, another thing that might be useful when starting out with a new dataset is understanding its general structure. One way to do that is using the head function, which returns the first 5 rows within the dataset. Let's run it. and we got the first 5 rows. We didn't have enough space to show all of the columns, so we got these 3 dots instead of the missing columns, but we got some general idea about the structure of each of these rows. By the way, notice that the indexes appear twice. So here are the indexes on the first column, and here they appear once again on the second column. The reason is that the dataset itself contains the index for each of the rows, but Pandas wasn't aware of it. So it generated an index for each of the rows itself. And as a result, we got the index for each row twice. One value is the one generated by Pandas, and the other value is the one read from the dataset. That's the reason this column is called unnamed. It doesn't have a name because it's not part of the dataset. It was added later by Pandas. This column, on the other hand, is part of the dataset, but a name wasn't provided for it. Whenever a name isn't provided for a column, it uses its index as a name. And that's why it got the default name, and it's called column 0. If we want to inform Pandas that the dataset itself already has a column containing the indexes, all we need to do is to provide the value to the call index parameter when reading the CSV file. So here, when reading the CSV file, I'll provide the value for the index call parameter. And in our case, it's the first column that contains the indexes, so the value needs to be 0. And if we run our program now, we can see that now we only have one column containing the indexes, and that's the one from the dataset itself. And we no longer have the unnamed column.